The queen's pantry has one drawer that contains forks and knives. The servants take some of them out to set the table for the dinner. Every individual table setting has exactly one fork and one knife. The servants use two-thirds of the forks and three-fifths of the knives in the drawer. What fraction of the total number of knives and forks are being used for the dinner? I'll solve this problem visually. If you want to try it, you can try it. It's a good time to pause the video right now. And this problem can also be solved algebraically, so you can try it algebraically as well. It's a good idea to try to do it in both ways and see which one makes more sense to you, what are the connections between the two. But I'm going to show this problem visually on the next few slides. What you have here is the question in smaller font and some pictures. Suppose this is two-thirds of the forks. That should be the same length as three-fifths of the knives because they are the same in number. If you have 500, if 500 forks represent two-thirds of the forks, then 500 forks will represent three-fifths of the knives. If 1,000 forks represent two-thirds of the forks, then 1,000 forks will represent three-fifths of the knives. Having said that, if this is two-thirds, I need to find one-third would be this much, one-third, two-thirds, and all the forks should be represented like this. This is the other missing one-third. These are all the forks, and this is two-thirds of the forks. Okay. Using the exact same principle, three-fifths of the knives, take this pink strip, cut it into three equal parts. One, two. Okay, I have three equal parts. That's three-fifths. I need two of those, two more of those. Excuse me, two more of those. That's four-fifths. Just eyeballing. And that's five-fifths. It's not perfect, but it works. So this is five-fifths of the knives, all the knives. Three-fifths are here. These are all the forks. Two-thirds are here, and two-thirds of the forks equal three-fifths of the knives. There's one catch here. These chunks in the fork section and in the knife section are not cut into equal pieces. We have to make them equal if we want to compare. What's a good strategy to do that? Now, I'm going to use a different color. Now, this pink strip is cut into three parts. And this pink strip, we're just talking about the pink strips, not the whole thing, cut into two parts. So I'm going to take this three, cut each of these into three parts. One, two, and three. Again, one, two, and three. And I have to do the same with this part because I want everything to be the same size. Okay, now originally this pink strip was cut into two parts. I'm going to take that two, cut each of these smaller pink strips into two parts, two equal parts. Another set of, two equal parts. Everything should be cut into two equal parts. And actually, we're almost done. Now take a look at it. Why does this work? Originally, this pink strip was cut into two parts, and this one was cut into three parts. So if you cut this one into three, there will be six equal parts. And if this was cut into three equal parts, and you cut each piece further into two equal parts, this will also be cut into six equal parts. This is cut into six equal parts. This is cut into six equal parts. They were originally the same size. Each chunk has to equal each other. That's the explanation. Now, these are all the forks. These are all the knives. Let's use a different color. So how many parts do I have here? I have 9 parts for my forks. And I have 3, 6, 7, 8, 9, 10. 10 parts for my knives. Okay. Out of 9 parts, 1, 2, 3, 4, 5, 6. I'm going to put 6 here. 6 of them are being used. Out of 10 parts, 6 of them are being used. So what part of the forks and knives are being used? I'm going to say 6 plus 6, 12, divided by 9 plus 10, 19. That's our answer. This part of all the forks and knives are being used for dinner. That's my answer. If you really understood the previous one, I want you to try this problem. This one, the one you see on the screen, is simpler than the previous one. However, give it a shot, and the answer to this question appears in the description of the video. Thank you.